question number 12. As long as you follow with me, you shouldn't have any problems. When you're working with empirical formulas that we had before, you have to look at what each one of those percentages are for each of your elements, and we're going to treat those as if you had 100 grams of this compound. If you had 100 grams of the compound, we can change that 38.8% to grams of calcium, because 38.8% of 100 is 38.8 grams. And we'll do that same thing for phosphorus. If you had 100 grams of compound and 20% of it was phosphorus, then that means that you'd have 20 grams of phosphorus. And if you had 100 grams of this compound and 41.3% of it was oxygen, that means that 41.3 grams of this compound would be oxygen. That's your first step. Second step, we have to figure out how many mole of each of those each of those elements are within this compound. So we need to divide that value, just like we did on the front side. We need to divide each one of those values by the molar mass of each element. Now you get those values right from the periodic table. So for phosphorus, we'd have 1 mole phosphorus. That is 30.97 grams of phosphorus for every mole. Then oxygen, by this time, you guys should be able to remember that one without going to the table. All right. What we do is you have to divide that out to get your number of mole of each one of those. If you recall, you cannot take and round that off any sooner than 4 places past the decimal. So for your calcium, you're going to end up with 0.9681. For your phosphorus, 0.6458. And then for your oxygen, that would be 2.581. I believe it just comes out to be that. Now, at this point, I'm not going to lead you much more than this. We have to divide by the smallest one for each of those values. Right? The reason why we're dividing by the smallest one for each of the values is because that's going to give us a relationship of calcium to phosphorus to oxygen. So we're trying to figure out what those little subscripts are in the empirical formula. So whatever those values come out to be, we're going to put that number right here. We're going to put this number right there, and then we're going to put that number right there. But there's going to be one small problem with this, and I'm not telling you what it is. You have to figure this out. Recall that you can never have a partial atom at the bottom. If you end up with something that is a 0.33 or a 0.5 or a 0.25, you have to multiply all 3 of those values by something until you get a whole number. That is what you'll record for your final answer, and we'll circle that up when you're finished. That should take care of number 12 for you.